There we go. Now we will go ahead and be able to get started. I would like to introduce you to our presenter, Curt Hofmeister. Curt is a licensed professional engineer who has used visualization as an engineering tool since the middle 1980s. His passion for immersive visualization began in the middle 1990s as a researcher working with ICEMT, Iowa Central for Emerging Manufacturing Technology, now known as VRAC, Virtual Reality Application Center at Iowa State University. Since helping start Mechdyne in 1996, he has 20-plus years experience designing, installing, and supporting 3D and immersive visualization systems. Today, Curt continues to be a driving force behind Mechdyne's innovation and technology. Curt?
Thank you, Mandy. Welcome, everyone. Today, we'll talk about being ready for virtual reality. This webinar is about the steps you need to take to gain benefit from using VR in your workflow. Much of our design data and models are 3D, yet we still tend to view and work on them on a 2D desktop monitor. Utilizing VR requires using your 3D data and moving to a fully immersive visualization. So let's start with the definition of VR. Virtual reality, or immersive computer simulated reality, is a computer technology that replicates a real or imagined environment and simulates the user's physical presence in the environment in a way that allows the user to interact with their data. Virtual reality creates a sensory experience which can include your sense of sight, hearing, touch, smell, and taste. Talking about VR reminds me of this Confucius quote, "I hear and I forget. I see and I remember. I do and I understand." Now, I doubt Confucius was talking about VR, although he did understand the benefit of using multiple senses to learn. VR engages several of our senses, creating a memorable, immersive experience and opens the way for enhanced understanding and learning. So, are you ready for VR? Here's a quick agenda for our webinar today. We'll discuss VR readiness with several examples from different industries and boil down to a few simple steps. Some other considerations for your specific VR solution will be discussed. And finally, we'll touch on some VR display options. First, a nerd quote on technology. Technology provides no benefit of its own. It is the application of technology to business opportunities that produces a return on investment. Today, I'd like to focus on getting you ready for the application and benefits of VR, not on the technology details. We could certainly talk about display resolution, computer power, etc., but we'll save that for another time. Instead, we'll look at several examples of how industries have found business value using VR. Asking why and identifying your need is the first step toward using VR. It's all about improved ways to engage, visualize, and interact with digital content. This is about the efficiency and effectiveness of how your digital content is used. VR can increase the usage and value of the digital assets your company already has. Some of the valuable characteristics of VR, this ability to interact on an immersive scale, is critical. Often we're talking about life-size one-to-one scale, although we can also shrink down to the micro scale and explore tiny structures, or zoom way up to a hyperscale for something like a large construction site. Another value is the collaboration with one or more participants. Experiencing a virtual environment is not just a visual scene, it's also gaining understanding from audio and spatial cues related to that environment. How the virtual environment is rendered can also make it even more realistic, and is often done for training and simulation applications. All of these characteristics contribute to our understanding of complex problems and data sets. So let's look at some examples of how VR is used in different industries. Maybe some of these are similar to your own needs. The first example is well established as one of the original VR use cases. Product design and virtual prototype review is used in industries like automotive, aerospace, and heavy equipment. Review of design, assembly, operation, and serviceability can all be addressed with VR as part of the product design cycle. Once a product is designed, there remains many challenges to manufacturing it and the layout of the manufacturing facility. VR is considered a safe way to simulate and train for these production issues. For a manufacturer training application, VR is also an offline approach that does not tie up your production equipment. Most major oil and gas companies also use VR to explore seismic data and make drilling decisions. Again, this is one of the early adopter industries. There are actually several commercial packages specifically for this application. When it comes to using VR for medical applications, we look at an example from Monash University. There they conducted a significant study of Huntington's disease and the effects on brain physiology. On the order of 80 patients, pre and post condition, understanding the trends in brain structure and changes over an 18-month period. They used VR to accelerate discovery with comparative visualization of up to 80 scans displayed at the same time. This was done as a shared experience for multiple participants and researchers. The Cave 2, shown in the upper right side of this slide, is a display system that supports 2D and 3D visualization of the data, as well as immersive exploration of brain pathways. Other university research groups have long used VR with all manner of data types to meet their research goals. A more recent trend is using VR as an education tool in a teaching environment to help students understand and explore complex concepts. Here again is the hybrid display environment we call Cave 2. One of the Cave 2 uses is to combine 2D and 3D content for teaching and research projects. The system is the size of a meeting room and can accommodate groups of up to 20 people. The full system can be used for VR applications or just part of the system for showing 3D data as illustrated here. Military task training has used VR for decades now. The system shown here is for an Army medical team training. The dumbbell shape shown on the right is actually 24 immersive screens, creating 2 VR areas joined by a short corridor. Simulation can cycle between field combat environment to an evacuation and then to hospital scenarios. The focus here is on group collaborative experience. Another example would be the National Institute of Occupational Safety and Health. They use a similar system to simulate underground mining and other workplace safety scenarios. In many cases, these systems combine the virtual environment with physical props. Props may be the gear that participants wear, or may be using mannequins for some of the medical procedures. Another traditional use of VR is driving simulation. This applies to flight simulation and other equipment operation. The image on the left shows a virtual vehicle operated by a driver in a physical seat inside a large screen immersive display. One advantage of VR is an experience combining data from different sources. On the right, we see an engineering analysis results being visualized combined with the 3D product model. For this example, the ergonomics of a ridden motorcycle can be evaluated along with the results of drag force pressure simulation. Imagine you need to explain the inner workings of a complex machine, or how a cancerous growth was interfering with normal body functions. When we attempt to teach or communicate new ideas to others, it helps if we can show them the visual subject matter, as well as interact with them through verbal and nonverbal cues, such as pointing and gesturing. I bring this up now as one of the points you should consider when determining the best VR solution for your needs. For your specific VR use case, it may be useful or even necessary to interact with others physically, not just virtually interact with your data. VR facilities can also help communication between experts and non-experts, like a discussion between a product designer and the ultimate customer or user of the product. Non-expert will still be passionate about the product's usability and may have valuable feedback for the designer. Consider this next slide. What is one conversation worth? In this example, customer and engineers are immersed reviewing a new corn combine design. The customer points out an in-field modification they make to the combine so it performs better and is easier to service. This is something the customer remembered simply by being immersed in the new design. And yet it was a revelation to the engineer about a change he would have never known was needed or beneficial without the customer's input. So I can't stress enough the value of collaboration in a shared virtual reality experience. Stakeholders evaluating and commenting on the design concept may often uncover errors or discuss their initial concerns. Like here, product engineers sharing ideas with manufacturing engineers. One of my favorite things are the aha moments when you hear things like someone say, "Hang on, I see something here I haven't seen before." These moments are near priceless in terms of understanding and go a long way toward gaining benefit from the VR experience. So think about your current workflow. Where would you like to see improvement? And what is the value of that improvement? We're spending time and effort on physical prototypes when maybe a virtual prototype could address some of the same issues. What is VR worth to you? It depends on your answers to some of these questions. We have found over and over that organizations save time and money by adopting VR into their workflow. So back to our steps for VR readiness. Once we have identified a need and a use case, we need to identify what your 3D content is and what other content sources you might use. So our second step, what is your 3D content? So many of our designs and ideas now begin as computer models. This is our basic content for many VR applications. Typical sources would be computer-aided design files, floor plans, or even object and spatial areas scanned. 3D data is the basis of creating a VR experience. Generally, there is plenty of 3D raw data available. Besides CAD and floor plans, there are many other 3D data sources you can use. The medical field tends to use DICOM scan data collected from medical imaging machines. Sometimes additional processing software is used to assemble these scans into full 3D objects. A similar approach is used in the oil and gas industry with seismic survey data that we talked about earlier. For research and education, the content can also come from a variety of sources. This would include statistical data and theoretical data like the molecular simulation shown below on the left. So back to our steps for VR readiness. We've discussed identifying your need with lots of examples there. And we've discussed what is your 3D content and sources where it may come from. Some of the remaining steps, getting a workflow to get your content into VR, applications and middleware to work with that content, and then of course realizing the benefits of VR are all key steps toward measuring are key steps toward return on investment and tracking your success. So let's review these additional steps through looking at two more examples. One of our most common use cases is reviewing subassemblies and parts. It may involve teammates from manufacturing or service divisions and customers as well. If potential problems are found early during the design phase of the product, then its life cycle can save on costly change orders later, redesign, retooling, all of which is added expense to the overall production. For this case study, we'll look at a client, Genesis Systems Group. Genesis is the largest builder of robotic welding systems in North America. Genesis had an internal need to use VR for design, but quickly discovered how using VR and virtual prototypes would revolutionize how their clients engage with the virtual solution. So Genesis defined their need as several internal goals set by the design department. The internal benefits they hoped to realize were better design optimization using VR and visualizing life-size welding cell designs. This would streamline their development process, resulting in lower product development cost. Also, they hoped to improve collaboration between design and fabrication teams, also lowering their costs. Finally, an accelerated time to market would be the end result with these new designs. For content, they used several CAD packages. Most of their internal design work was done using the Dassault product SolidWorks. And yet, additional CAD often came from their vendors for the welding robots and material handling equipment they used. CAD also could come from Genesis clients for parts and fixtures, as well as facility floor plans. So content for a single design could come from as many as 5 different CAD packages. For step 3, they decided that all of their CAD content would be imported into another Dassault product, CATIA V5. This way, all the content resided in a single CAD format. So as part of their workflow, they used different applications to convert from one CAD program to another, something that is readily available. And in the end, they had all of their design consolidated in a single package. This made the choice for their 4th step, using Mechdyne's conduit for CATIA V5, an application that allowed them to visualize and navigate, as well as trigger assembly sequences and quickly switch between design options. So when it comes to VR application, this was their main choice for visualizing the data. So when it came to measuring benefits and return on investment from using VR, well, there were many internal goals, and these were really realized and met early on. What was surprising was a set of client-related benefits that provided Genesis the most value for using VR. Some of the client benefits realized were an immediate engagement with the design after the life-size walkthrough. The system they used is a curved 4x4 array of 3D flat panels shown here. It's large enough to provide immersion for small groups. After this walkthrough, customers report increased satisfaction with Genesis products. It's led to a reduced buying cycle time, with customer satisfaction being so high. They often uncovered critical off-agenda concerns like serviceability and material handling simply by walking through the design. This virtual walkthrough was an efficiently scaled ergonomic test of the proposed welding cell. In the end, clients perceived less risk and were willing to purchase sooner, which was a big benefit to Genesis. This quote from Genesis nicely sums up the value of VR for them. Initially, the Genesis sales team may have been hesitant about using VR Review for welding cells and walkthroughs to engage their clients. Although after quickly closing several large purchase orders, the sales and marketing team are now big proponents of using VR in their process. So let's look at another general case study from University of Wyoming, the Shell 3D Visualization Center. For this second case study, we'll consider their need for VR comes straight from the center's mission statement. That is to enable scientists and engineers to visualize and interact with highly complex data sets. Now, the center has available several immersive displays, including one large screen system known as a cave. Some examples of their teaching and research uses are listed here. As you can see, a university resource like this center supports projects from several different disciplines. If you are interested in learning more, they have also produced numerous short YouTube videos about their research and uses of VR. In the case of the University of Wyoming, 3D data is readily available from a wide variety of sources. The sources of their data is actually the least of their concerns. Their biggest challenge is the third step in our list, and that is a workflow. In this case, the University of Wyoming workflow depends very much on the research area and data types being used, as well as the VR applications selected to view and interact with the data. They have pulled together a suite of tools and packages that are part of their workflow to prepare content for use in VR. So the Shell 3D Visualization Center has this wide variety of Windows and Linux applications. Many of the ones listed here are commercial applications, although some are custom software or university open source developments. You can see from this list that the VR application chosen can be from a wide variety of applications based, again, on the research goals. In terms of measuring benefit, the University of Wisconsin is constantly adding to this workflow toolkit of software and processes. They measure value for the university like this is best done through sustainability and demand of ongoing projects. Many centers like this are multidisciplinary and benefit from a wide variety of experiences. Actually, the benefits just keep coming for the University of Wyoming. These are in the form of new projects, opportunities to engage with other research groups and with local industry. Plus, centers like this help attract new faculty and students to the university. So, this series of steps is our basic checklist for being ready for VR. I can't stress enough the importance of the first and last steps. Mech9 often works with clients to help clarify their need for VR, as well as measuring success and covering the steps in between. Okay, so we've talked about your VR readiness and lots of use cases. So what can we expect next, or where do we go from here? For your specific use, there are a few more things we should consider. So before finalizing a VR solution, there are things about your specific use case we should consider here. For example, are you wanting a single person experience or a group immersive experience? Will the group members need to see and interact with each other, or are they just viewing your data? Will participants need to reach for objects in VR, or do they need to move around, or will they be seated? Do they need to physically walk around the virtual objects? All these questions are related to the space, size, and type of display that best fits your needs. How well you can tolerate VR gear being tethered back to a computer, or is wireless a critical part of your solution, would be one more thing to consider. If we look at some additional considerations here, although we talked about reach and being able to move around, we still need to consider constraints on the space related to that range of motion, as well as the display type used. We'll talk more about display options coming up soon. Think about the length of your typical work session for your use case. Are you comfortable in working in VR for a long period of time? It's important to consider the use of physical items as well, as being part of your experience. For example, a driving simulation where you need a steering wheel and a seat is probably going to be necessary as part of that simulation. Today we focus on VR readiness, although there are a whole mixed reality spectrum to consider when defining your needs. So what VR solution is best for you? I think we can address that by taking a look first at a basic system. If I were presenting to a live audience here at MEC9, I'd ask by show of hands who has experienced a VR system. For those of you willing to play along, please press the webinar interface button for raising your hand if you have experienced a VR immersive display before. The button looks like a raised hand. So it looks like we have maybe a third or more of the participants have indicated they have experienced a VR system before. That's great. All basic VR solutions contain some common elements shown in this slide. These elements are common regardless of the display type used. So we have some basic things like computer, body tracking, the software interaction, but we want to be fairly agnostic in terms of the immersive display used here. So for those of you who raised your hands, you probably experienced a VR system before. Then it was one of the two types, either a large screen immersive display system or a head-mounted display. Head-mounted displays are often referred to as HMDs or headsets. Large screen immersive displays are sometimes referred to as power walls or caves. So it's hard to be up to date on current technology and not have heard of one of the many VR HMDs. There's more and more coming out on the market every day. The HTC Vive, the Oculus Rift, the Samsung Gear VR, Microsoft HoloLens shown here. All of these are pretty common popular choices, although there's many more in development and coming out through Kickstarter and new product launches on a regular basis. Many people would think that these products are brand new inventions, but actually the head-mounted display has been with us for a very long time. HMDs have actually been around almost as long as TV, going back to the 1960s, although they did not see serious use until the mid-80s. I have not tried the HMDs shown in the upper left or lower right, but I would like to someday. As you can see, the variety of products is nothing new to the market. On the other hand, large screen, spatially immersive displays have been around for decades as well. These displays have been a popular alternative to headsets since the early 1990s, when the cave was first invented. Simple displays can be a single projector, like the power wall shown on the right, or it could be an array of monitors, like the MEC9 ARC shown on the left. Both of these displays are fairly simple to set up and can be run by a reasonably small computer. On the other hand, we can go for even greater complexity and more immersion with something completely surrounding, like the cave shown here. This system is the C6 at Iowa State University's Virtual Reality Application Center. Once you step into this cube, you are completely surrounded on all 6 sides by your computer graphics and the virtual reality experience. Some clients also go with a hybrid solution, combining headsets with some type of large screen immersive display. Shown here is the Lockheed Martin Chill, their computer-human interface lab. Participants wearing HMDs are also body tracked, while other participants can view the virtual environment with avatars of those wearing HMDs. They view this on a large immersive display shown to the right of this image. With this setup, group collaborating in a large immersive display can review and help define steps for tasks done in VR. What we've shown here today are many display options. Let Mechdyne help you find the display solution that best meets your needs. Some of the takeaways from our display discussion is that there's really no one ideal VR display solution. It really depends on your need and applications used. A wide range of solutions are available, from single-person HMD to group immersive displays. And please keep in mind that one size does not fit all. Thank you for your time and attention today. I wanted to allow some time for questions, and I'd be glad to take those now.
Again, if you have questions, please use the chat feature in the bottom left-hand corner of your screen. I still have you all muted. We did have a question come in from Vivian, and Vivian would like to know about examples that have multiple people in an HMD. Are they occupying the same virtual space?
So thank you, Vivian. The question of multiple participants wearing HMDs in the same virtual environment is quite commonly asked. And it depends a little bit on the application you're using to experience a virtual environment. But the best example I can give you would be in the field of serious gaming or multi-person training. So the slide a few back showing the Lockheed Martin Chill Lab, that shows several individuals doing a task cooperatively in the same virtual environment. And the participants off to the right are also viewing those individuals as avatars as they do this task. Okay.
Great. And Vivian, if you have follow-up questions, please let us know as well. Sarah, the Wyoming YouTube videos that we talk about, you can find them on the Mechdyne website, actually. If you go to mechdyne.com and go to our video gallery, you can see them there. Or if you just search Wyoming, the Visualization Center, the 3D Shell, Visualization Center on YouTube, you will find them as well. I can also send you links, Sarah. I have your information, so I can send you links too. That might be the easiest way for me to get them to you. Another question asks, what SDK do you provide for VR? Does anyone use Unity, and how?
Thank you. That's a great question. There are many SDKs out there depending on the application used. But the short answer for Unity is certainly Unity is a very, very popular choice. Mechdyne actually has a middleware product called Get Real 3D for Unity that several of our customers use. And again, this is a middleware to enable your Unity environment to run within a virtual reality system. So it helps take care of some of the peripherals, the body tracking, and the different head points. But again, it's any virtual reality application built on Unity could then run with this middleware.
Great. Richard has the next question coming in. It says, has there been any breakthroughs on VR not using glasses?
Yeah, this is a question we often get. Whether it's a headset or glasses, many people prefer not to wear something on their heads. Today, the autostereoscopic display technologies just really aren't conducive for much long-term use in a virtual environment. We often are tracking things that claim to be a holographic display, and I do believe those are in our future, but that would be the closest thing to not requiring glasses, and none of those are really ready for prime time at this point.
Great. The next question is about the Lockheed Chill. It said, did Mechdyne help develop Lockheed's Chill facility? Has Mechdyne developed other multiple mixed VR labs?
Yes, actually we did. Mandy mentioned earlier on our website you can find our gallery, or you could certainly search on Lockheed Chill and find related videos. Mechdyne was the system integrator for that installation, working very closely with Lockheed. So in that case, the facility was something we installed, integrated, and still service today. Working with them for their application, you can imagine that the headsets they originally used several years ago have evolved as they've looked at different products coming onto the market. That's a way we continue to engage with them. Other clients, an example might be General Electric Consumer Product Division. They also have a mixed reality lab using large monitor displays along with HMDs, so they can do this group cooperative experience.
In the second part of that question for you, if we've done other mixed labs, we have just worked with Wichita State University to install a very large, what we call a flex, and they also have HMD and motion capture up in theirs, and we're literally have teammates on site right now finishing up that installation. If you go to our website, again, sorry I keep pushing up, that's where all of our content lives. You can find articles about Wichita State University, what their lab's looking like as well. Another question from Robert, is exploring design options part of the originating 3D software or a product of Mechdyne?
So typically that is part of our client's workflow. In other words, they'll have a design package they do their product development in, and as part of their process or their workflow, they'll be looking at several design variations. So when it comes to visualization, we are enabling the display and the virtual reality application, maybe the interaction, but it is still originating with the customer's process for the design development.
Great. Next question. How has the proliferation of HMD solutions impacted the adoption of new and upgrades of existing large screen display systems? This isn't an uncommon question for us these days.
Yeah. So this question definitely is part of many conversations. And it goes back to that fundamental question, what is your group collaborative requirements in terms of how you want to visualize data? So Robert, in terms of using a cave system, what we're finding more and more is we're tending to do hybrid uses where the mix of HMD and some sort of a large wall display or actual cave is still quite common. Again, the cave or the wall is much more conducive to a group review and experiencing the environment through that type of collaborative discussion.
Perfect. And then a follow-up question to when we were talking about the SDK that we provide for VR, and if anyone uses Unity, it says there's a cluster supported.
So Mechdyne's middleware is cluster enabled. In other words, if your display or your solution requires multiple computers to drive the same environment, the Mechdyne middleware then synchronizes multiple instances of Unity running on each of the PCs. So yes, it is cluster aware.
Another good question coming in. Do the participants in a cave need any other devices, or they only just kind of enter as they are, or do they need glasses, things like that if you're a visitor in a cave?
So for a cave system, typically there are two key things that you need. One is glasses. That enables you to see separate right eye, left eye images, so a stereoscopic view as possible by wearing the glasses. The second thing is some sort of an interaction device. And many times that's as simple as an Xbox 360 controller. That gamepad gives you a way to navigate through the environment, as well as a lot of buttons that can be programmed for different options within your application.
Amy has a question for us. Has there been any new updates related to wireless headsets used in VR?
In terms of updates, I guess I don't have a good answer there. We do have hardware available that we can make any HMD wireless. There are certainly some on the market, like the Microsoft HoloLens, that are already wireless, although those tend to have limited graphics processing and memory on board. So they're kind of limited. You wouldn't use it to explore a large virtual environment. Instead, we would use something to make video wireless attached to the headset you'd be wearing.
Perfect. Follow-up question from Vivian. She's most interested in using work where we use technology to address isolation or loneliness. Do we work with haptic suits, and are we exploring this in any capacity?
So haptics, or our sense of touch, has been a challenge issue for many virtual reality applications. And we're constantly monitoring new products and new research as it comes available. In terms of loneliness, I would say that wearing a headset can be very isolating for some people, whereas a group collaborative display experience gives you more of that social interaction to talk back and forth, to point and gesture at objects. If you're researching loneliness, I would certainly point you to some of the university groups that have already explored that same topic.
Right, very good. Brad had a question. He said, what is the best way to determine if VR is right for my business? How do I get started?
Okay.
I would tell Brad we'll call you right after this, but I'll let Curt give you the official answer.
Well, I like that answer. So in determining if VR is right for your business, it comes down to the need and looking at your current workflow. Now, VR could be a major disruption, but that's really not what we're advocating here today. It's looking at your workflow in places where a virtual prototype or a virtual model of the environment your product is used in would have direct benefit. So if you're producing a virtual prototype now and you're doing that early in the design phase so that you're looking at maybe variations in the design, we'd encourage you that is a good point to avoid producing the physical model. Instead, rely more heavily on the virtual model. At some point later in the design phase, you may still move to physical prototype, but again, looking at your process, there's probably points now where we can take advantage of the digital assets you already have.
Perfect. Jim has a question. He says, has Mechdyne done any hybrid systems incorporating the HTC Vive? What do you feel is the best HMD on the market today or on the horizon?
Well, I don't think there's a clear best HMD, although the HTC Vive is one we've certainly worked with and a very popular choice. So today, the hybrid systems using a stereoscopic flat panel or wall type display along with an HMD, yes, we have done that with the Vive as well.
Perfect. Another question, and this is a great one from Brad. What has been the typical ROI of a VR system been, step 5, that we talked about?
So in terms of ROI, it really depends on the industry and the application. So I mentioned physical prototypes. If you spend multiple thousands of dollars making physical prototypes as part of your process now, then you can look to save some of that by using virtual prototypes along the way. If you have a time penalty from producing a physical prototype, again, with the virtual prototype, you immediately can save time and look at more variations in a shorter period of time. So those are all kind of direct savings. Another savings that's a little more intangible is the savings you get from avoiding problems further in the product life cycle. In other words, if you've ever had to make a design change, especially once a product's gone to manufacturing, that can be extremely expensive. So for companies who've kept good track of their metrics over time, they can see that they are producing products now with less rework or correction in production than they were previously. And that is a very big savings for those companies.
And I'll just jump in quick too. As Curt said, it really does kind of vary depending on your industry. Some are more intangible than others. Research education, obviously, lots of times you'll see different things. The students, if they're using it for learning, they have the higher involvement with learning that comes up. We've talked about it as a recruitment tool. Lots of times it's a flagship piece for these universities. So it really does kind of go back to that first step of identifying your need and what that need is, what your challenge is that you're trying to solve, and then what we can do on the back end to make sure that happens for you. Okay, a few more questions here. You guys are doing great hanging in. This is what we like. We'd rather the questions at the end than more time just listening to us talk. So let me go down here to see what we have. Do we have a plugin for the game engine Unreal like you do for Unity?
Yes, good question. We do have a plugin for Unreal. We call it Get Real 3D for Unreal, and it is about to be released now as we speak. I don't have the exact release date in front of me, but it works very much like our plugin for Unity, since Unity and Unreal are two very common game engines. The plugin will synchronize multiple instances, so that can be a display with multiple displays together or multiple participants within the same virtual environment.
And we'll take a couple more questions here. And if we don't get to your question, we will answer them afterwards. I have the name, and so we can follow up with you if we don't get your question answered. A question from Aaron. Some basic system design issues, if you share this or not. So do you use multiple processors for screens versus single processors? Use of display, distribution, amps, things like that. Also, how has higher resolution, 4K or other demands affected how your systems are going together? Great question.
Yeah, good question. Aaron, there are so many different ways that can be carved up. The most extreme would be a single computer with a single graphics card and using only one channel out of that graphics card per display. The other extreme would be using one computer with multiple graphics cards and multiple graphics channels out of each card, driving numerous displays. So you can see that there's very many ways that can be split up. And it kind of goes back to this question earlier of cluster support. Mechdyne typically provides multi-channel display systems, often driven by more than one computer. So we would effectively split up the graphics channels based on the performance and budget requirements that we're working with for your solution.
Great. And then Emma Jane said, can you please comment on any developments regarding haptic devices?
So haptic devices, there's really not much I can comment on. My experience today is that there's a lot of research being done with haptic robotic arms and devices like that. There's a little bit of research going around on things that are more tactical, like your hand is in a field where you feel airflow changes, or you feel a vibration of a sensor, or maybe you feel even an electric stimulation. Those things are a little more research-oriented. None of them are productized that I'm aware of in a way that we would readily deploy now.
Great. Another question says, when selecting a computer to drive the VR system, what is most important to consider? CPUs, graphics?
So we would answer that going back to the application you intend to use for the VR display. In other words, are you looking at graphics with very simple color and not a lot of photorealistic detail? Then we would certainly get away with less powerful CPU and less powerful graphics cards. On the other hand, if you're looking at a very high level of realism with rendering and lighting and different graphics techniques, then I would say the most important thing is selecting a high-end computer graphics card with plenty of texture memory available on that card. But again, how we split that up depends on the ultimate application you want to run. and how it performs with that hardware.
Okay, I'm going to take about 2 more questions here. I love them. These are great questions coming in, and we're putting Curt to the test, which we always enjoy as well. Another question from Richard says, we often use 3D printing for critical time-constrained projects. This obviously can help us get it right the first time. Do we have any use cases concerning metal printing and cost savings? These 3D printed parts are often made out of titanium.
Yes, typically, Richard, this is not our expertise area in terms of 3D printing. Although it's an accepted alternative for those physical prototypes, we tend to focus more on the virtual prototype. So my understanding is that these can still be quite time-consuming to print out. The question is, how usable is the physical part after you've created it? So I would rely on the virtual design to look at different part designs, maybe look at the analysis of those designs before actually doing the 3D printing of a physical prototype.
Okay. Question from Jess. How do manufacturers deal with high-feature, large 3D models? Is it necessary to convert files into simpler geometry, smaller files, or would we be able to explore an entire machine, say 30-foot-long machine?
Yes. One of the slides earlier in the presentation actually showed a road grader on a display. I don't remember which slide that was, but in terms of a big, heavy piece of equipment like that, there is some work done to simplify the file. It's not so much converting or what we call tessellating to simplify the file. It's more like removing parts that aren't going to be seen anyway. So if your model contains all the internal details of the engine, and yet you're interested in the structure and the body, then there's really no need to include that in the visualization. In other words, that is just weight to the model that you really don't need. So rather than spend time simplifying the geometry, we tend to strip out geometry that's not needed to the simulation.
Okay. One last question for us before we wrap up. It says, I guess VR could be helpful for certain disabled people who cannot move easily by themselves. Wondering if there's any existing applications for VR for such a case.
Yes, I just recently read a research paper where the researcher was using head-mounted display to place a disabled person in a virtual environment. And this was not so much a game as a series of tasks that included this disabled person to reach and move more than they might normally. So the VR environment and the tasks they were doing were the motivation to encourage movement at the limit of their range, more so than they might do with normal exercises. So the VR helped engage the person to do more movement within the range of their capability. Okay.
And I said last question, but I'm going to sneak one more in because we do have 5 minutes, okay. So how dare we not use all that time. Which solution is most used by companies in the aerospace industry?
The companies that Mechdyne tends to work with pretty heavily use Dassault software products and some Siemens software products within that industry. So that is the CAD package their design is based on, and with the rest of the lifecycle products, it can be related to the manufacturing and ultimately the visualization. Now, even if they're using a Dassault or a Siemens product for the basic design, they may still use something else for the photorealistic viewing if that's a marketing concern. So an example, Gulfstream is a user of VR, and they oftentimes will import their models and then using yet another package, add a lot of photorealistic details for the materials and the wood grain and things like that. But again, I'd go back to those 2 basic vendors. There's certainly other options out there as well.
How about in terms of hardware solution? What do we typically see them using to visualize it on in terms of that larger immersive system?
Today, it tends to be the large immersive displays, what we consider a walk-in display. Now, it may not be large in terms of physical floor space, especially if they're simulating the interior of an aircraft. But on the other hand, it may be wall-sized for doing a product review.
Perfect. Thank you, Curt. Well, I will stop our questions right now. Again, if we didn't get to your questions, we will follow up with you after the webinar. This was recorded, so we will also be sending this out if you would like to listen to it again. Thank you all so much for joining. Curt's contact information is on here. You can always go to our website, mech9.com. And as always, please follow us on Facebook, Twitter, LinkedIn, all of those awesome social media sites. Thank you so much for your time today, and we hope you have a great day.